Augmented reality also allows you to create a telepresence link where you can link up directly with the service center and talk to the most experienced engineers that will see exactly the same thing that you see at the same time.
Beyond Clean offers a creative look into the inner workings of a healthcare industry committed to getting it right. Every instrument, every time. Join us every week as we explore the hidden world of one of the most important aspects of safe surgical care. And now your hosts, Hank Balch and Justin Poulin.
This week on Beyond Clean, we welcome Pawel de Sternberg Stojalowski, Managing Director, R&D Engineer, and Consultant for Decontamination of Medical Devices at Aseptium. Paul has a master's degree in mechanical engineering and a bachelor's in robotics and mechatronics. His background gives him the ability to combine and reinvent solutions and technologies, and that's certainly the case this week, guys. There's really an interesting combination of technologies that we'll talk about with Paul, and also emerging technologies. Everybody's got a VR headset for their smartphone, I swear, these days, and we'll get into some applicable strategies in sterile processing for that technology.
Yeah, this is one of those guests that's really going to, I think, take us to the cutting edge of where we want technologically our field to be in another, 5, 10, 15 years.
I've said it before, guys, and I'm going to say it again. These are global challenges that we're confronting, and I'm excited to bring on another international guest with that international perspective. He was recently at the World Congress of Sterilization in Bonn, Germany, and had some great feedback just through the exhibition hall for some of these technologies and solutions that the company's coming out with. But for the podcast, we want to make sure to keep this reach global and our perspective, not only the challenges that are found inside of our facilities, but also the solutions that are coming in from across the world.
ISHM is the International Association, and for those of you who maybe haven't caught all of our episodes, Daniel Kuhl was our previous guest that was from across the pond, as they say. So definitely check out that episode with Daniel. As a reminder, you can subscribe to Beyond Clean on iTunes, Stitcher, Google Play, and Spotify, or search for Beyond Clean on your favorite podcast application. We can also be heard on the Sterile Education app available on iTunes and Android. Follow Beyond Clean on Twitter at Beyond Clean Info, Facebook.com/Beyond Clean Podcast, LinkedIn.com/company/Beyond Clean, Instagram is Beyond Clean Podcast, and our YouTube channel, YouTube.com/Beyond Clean, featuring Beyond the Headlines with Mike Matthews, Real Talk with Bob Mars, and Fighting Dirty with Hank Balch. Contact us by emailing info@beyondclean.net. Are you a hero? Do you want to attend the ISHM Conference and Expo? Newsflash, your free weekly Central Service newsletter, announces this year's CS Week Challenge, where you can be awarded a scholarship to attend the 2020 ISHM Conference and Expo, plus receive a 1-year paid ISHM membership. Let the team at Newsflash know how you keep patient safety high by entering at ultracleansystems.com/achievers. 3 entries will be selected, and the top recipient will receive $500 in expense assistance to attend the event in Chicago next year. Go to ultracleansystems.com/achievers today. Is your central service or sterile processing department prepared for a regulatory survey? If you can't answer with a resounding yes, you should contact Beyond Clean. Our experts will perform a survey in your facility to help you determine your survey readiness. We can evaluate acute care, ambulatory, and dental facilities. Our team will guide you through the survey process to ensure that you are beyond ready for your next survey. And we can stay with you after the consultation, offering virtual consulting and mentorship programs to maintain the progress you have made and to continue making process improvements. Contact us today to schedule a free 30-minute initial consultation.
You're listening to Beyond Clean, the global voice of sterile processing.
Joining us now is Pawel de Sternberg Stojalowski, Managing Director, R&D Engineer, and Consultant for Decontamination of Medical Devices at Aseptium. Pawel, thanks for coming on board and joining us for the show. And I know that there's a little bit of a time difference, so I know it's getting late in the evening there, and we appreciate you accommodating the schedule and sharing a very unique technology with us today.
Thank you very much for having me. It's really a pleasure to know that we are actually doing something to broaden the knowledge of decontamination technologies and science and putting that in front of people across the globe, I think.
I would say maybe just give us a background regarding your role with Aseptium, and then we can learn a little bit about the company and dive into some of the unique technology.
I started with decontamination sciences over 10 years ago. As probably most of us, I ended up there by a lucky coincidence. Right after I graduated, I got a job with a company called MediSafe, and I actually relocated from Poland to the UK and started working with them, developing at the time the most advanced washers and working with the most complex instruments that were out there. So I got a lot of exposure, and that was pretty much thanks to the education that I had. I've got degrees in mechanical engineering, automation, and robotics. So that combination of understanding the mechanical, electronics, and process control gave me the ability to actually look at more complex systems from a slightly, I would say, wider perspective. So that's really how I ended up in decontamination. And I was initially completely mesmerized by different technologies, by different problems, because it's one of those disciplines where you have an amalgam or a mixture of different disciplines of science and engineering meeting in one point to solve particular complex problems. And that was something that pretty much from the very beginning very much enjoyed. I had a very brief encounter with aerospace engineering, and I was working in a design office for turbojet engines for helicopters and aircrafts. And then I didn't really like that. I didn't like being a part of a massive organization where you have thousands of engineers working collectively on a big project. Changing that scene to working for a much smaller company, but having the responsibility over the entire research and development process was something that I really enjoyed. And I've been doing that for several years, developed at least a dozen different washer disinfectors with ultrasonic functions, mostly looking at reprocessing of the likes of Da Vinci instruments. Later on, I decided to change the scene and pretty much got a little bit fed up with decontamination. So that was an interesting conundrum, because in 2012, I thought that I'll probably never come back to decontamination. And you see, here we are. I went back to the university to do an MBA because from the technology point of view, there was no natural progression path for me. After MediSafe, there was no one else on the market developing better, more advanced technologies, so I sort of had to reinvent myself. The interesting thing is that once you are an engineer, it's quite difficult to change that framework and change that way of thinking. And after half a year in the library at the university, I've started really missing the lab and making new technologies, tinkering with engineering. And I also at the same time realized that I've been always previously approaching decontamination problems purely from the engineering perspective. And I understood that I was missing that element of understanding of the infection control, the microbiology and biotechnology that stands behind decontamination. And exploring that was actually something that allowed me to think about how much more we've got to solve, how many more problems are there that we haven't even considered. And that led me to come up with my own ideas. And the only way to implement that was really to start my own company and do things my own way. So I would say that this is what led to formation of Aseptium. And in 2014, finally set the company up and started looking at problems with sort of my own perspective on things. And from the very beginning, what was really important for me is that we have a very specific philosophy inside of the company. And the most important, I think, element for me was that I made myself a promise to always use the scientific method approach. So finding out what really sits behind the problem. So really trying to find out either through academic research or through experimentation, what are the overarching reasons or the sources of problems, and then solve them. One of the major issues that I've taken on the agenda very early on was the fact that if you spend a lot of time trying to develop equipment and processes for lumen cleaning, especially when you have very fine lumens and very complex instruments, very often when you look at robotic instrumentation, apart from just having complexity of the external shape, you also have the internal mechanisms that are hidden inside of channels. You have linkages, you have joints. And we didn't really have a technology to be able to evaluate that in situ in hospitals. And that is something that leads to a lot of, I would say, anxiety in terms of how well our processes are actually performing if you cannot really evaluate them on a daily basis. But that led to another major discovery, I think, on our front, was to find out whether there is actually a problem of cross-contamination between instrumentation.
I was going to say, just on that,
Sure.
The non-recirculation, you were literally just teeing up one of my big questions, or maybe we need to elaborate it. This recirculation of contaminants is really a big issue, and I think not just from the standpoint of bioburden and other biomaterial that may be in there, but also the emphasis of just good, proper rinsing from even the chemicals that are used in the process.
Absolutely.
So maybe you could talk a little bit about that.
Certainly. So this is exactly what I was sort of heading to, because the problem of cross-contamination between instrumentation inherently comes from the way how we are reprocessing our instruments and what technologies we've got available. So when you think about the fact that most of the technologies that we are using today, washer disinfectors or washers, work on basically the same principle as a dishwasher. You put water into the sump, then there is a pump that recirculates that water, and gradually you are removing contamination from the surfaces of whatever you hold in your washing chamber. So when we are talking about dishwashers, then this is fairly simple, because we don't have any of those very complex shapes. We don't have the geometries where we have to remove contamination from tiny, intricate details like we've got in the case of, for example, ophthalmic lumen instruments. So now we get to a position where we have to sort of understand that once we remove the contamination from the instruments, it actually circulates inside of that water that is washing it. So in case of simple instruments, it's not a big problem, because after you've replaced that water several times, you get your right cleaning effect. But what actually happens when we have those instruments that do require this special attention, where you have very narrow channels, where you have crevices, mechanisms, and so on, where these actually work as traps for contamination. Imagine that you are constantly flushing your tiny narrow lumen with not only biological content, but sometimes you've got floating debris of all sorts of different types. When you consider those tiny intricate elements and the fact that you are recirculating water and they are being continually washed with water containing diluted bodily fluids and so on, now ask yourself a question. Have you ever seen a piece of debris, for example, swinging from a spray arm, whether it's a piece of cloth or bits of fiber or bone tissue just being stuck in the hole from the spray arms? I've seen that countless of times. And, despite the fact that we've got all sorts of different filters and so on, somehow it still gets there. So the question is, what is now the probability of a piece of debris ending up actually inside of your luminant instruments or hollow instruments? Okay, it's the same system. Maybe it has got a slightly different pump, but it's still taking it from the sump and putting it back into those instruments. So we've got a major issue over here that we've got to address. So I started thinking at the time, is there a way we can actually eliminate the need for recirculation, and whether we can do it by design? Because if you would change the system to a situation where that dirty water is not reused, you would actually solve this problem, not only, eliminate 50% of it, but you would, by design of the actual washer, you would change the paradigm, because it would no longer be the case that dirty water is recirculated back into the instruments.
Yeah, so before we get too deep into that recirculation question, because I want you to really illuminate what that solution is to get past the challenge of recirculation. But I want to put you on the spot a little bit here and say, from what you know of the technologies in the industry and just the practice on the front lines, if you were to gauge percentage-wise, how many instruments today with these complex lumens, with the existing technology that's out in the market, are actually getting properly cleaned?
So I would say, and I always sort of look at the ratio between the really complex instruments and the more simple ones as sort of 80-20 rule. So I would say that 80% of standard instruments don't really require extra attention, and the current technologies are adequate for them. But the remaining 20%, and we are talking about highly advanced instrumentation and very specific to certain surgical procedures, yes, I would say about 20, maybe 25%. This number is going to grow because, as you very well know, the surgical technologies are advancing very quickly at the moment, and we are entering a time where we are looking at very specific, almost bespoke sets of instrumentation for particular surgical procedures. And we are even, taking that to an extreme in certain cases. So the robotics is a prime example where you have, a set of several instruments that are very, very specific and only work in a certain environment, and they are only used in a certain way. And if you look at, for example, the endo-wrist instruments from Da Vinci, they do require special attention from the decontamination point of view, just because of that complexity that we inherit from their design. And if you consider at the moment that for the last several years, I would say last 5 years, there was consecutive increase in investment into new surgical technologies, and that was at the level of around 15% per annum. The question is when those instruments are going to become available. And from the best of my knowledge, most companies who are looking at very advanced instrumentation are looking at very specific cases. So you would have either solutions for spinal surgery, neurosurgery, hip replacements, and orthopedics, and they will be robotized, and they will have very, very specific types of instrumentation. So even if you dismiss robotics, because this is yet again quite a niche market on its own, it is growing rapidly, but it's still as a percentage quite small. Just look at, for example, the ophthalmic instrumentation. It's completely different. The nature of contamination is different. The instruments are very intricate, very small, and they require their own processes. So in general, I would wrap it up and say that it is about 20 to 25% of instruments that really require special attention.
No, it's great, Pawel. And I guess on this next point to the recirculation, because I know folks that's still sitting in the forefront of their mind, how are you getting around that same water challenge in these ultrasonic cleaners?
The main issue you've got is the fact that as standard, the machine fills up, the standard washer disinfector would fill up the sump, and you would have that amount of water being driven by the setup, by the type of the pump you've got, and you would have to have the minimum amount of water. And I thought initially, can we do something about that? Do we really have to recirculate? Do we have to get the water out of the sump and back into the chamber? And maybe there is a way of actually doing that externally. What I've realized that if we used an external source of water and pump it directly through the spray arms into the washing chamber, you solve the problem by design, because you are no longer requiring to take the water from the actual chamber. So this was the moment where I realized that we've got a system that could potentially eliminate recirculation completely by design. So what we have at the moment is a system where, for the first time, we are not really restricted by the fact that you have to fill certain amount of water to your chamber to actually start the process. This is a fundamental thing because if you consider now how we are, for example, administering chemicals into washing processes, we dilute them in that amount of water that you've got per stage. So imagine that out of sudden you really don't have that restriction. We can now develop completely new processes that were not available before just because we had to put that water into the sump. So at the moment, a big part of that new way of thinking is to change the paradigm and think about integrated processes where you are able to include a lot of the manual pre-processing tasks like flushing with sterile water, like purging with chemicals, and integrate them into one continuous validated cycle. That was the core of the technology, the fact that we are no longer taking the water back from the sump into the instruments. Obviously, you'll say, okay, how is it possible that you are not recirculating water if you are actually submerging the instruments completely for ultrasonication? So yes, this is a very valid point, but we have to remember about one critical element, that what we were predominantly trying to resolve is recirculation inside of lumens. During ultrasonication in our systems, water is being fed through the lumens always out of the instrument. And this is always fresh water. So we are not taking any dirty water, no diluted contamination back into the instruments, but every time instruments are flushed, they are flushed with fresh water and fresh chemicals. What is also super important over here is that for the first time, we've got the ability to differentiate between the concentration of chemicals that we use for external cleaning and internal cleaning. We know very well that the cost of reprocessing very well depends on the type of chemistry and the quantity of chemistry you use. So for the time being with conventional technologies, it was quite expensive to increase the concentration of chemistry just to apply a high concentration of chemicals to the inside of the instruments. While in our technology, those two systems are completely independent, so we can actually have high concentration of chemicals exactly where they are needed and at very, very low quantity. So we are no longer diluting in 20, 30, 40 liters of water. We just have a couple of liters of water, and that goes through the process where we can then precisely deliver the chemistry to where it's needed, to the inside of the instruments where you have a lot of contamination that needs to be removed throughout the instrument.
Yeah, that's fascinating. I wanted to ask you, earlier in the segment, you mentioned that part of what keeps you going is that there's just so much that needs to be done. And we wanted to just ask, what are a couple of those things that in your mind are still kind of glaringly obvious things that need to be fixed, but just nobody's really even looking at?
So when you want to look through the sort of biggest challenges that we've got within the decontamination spectrum, I think that there are major four issues here. First one, the surgical instruments and how they are changing in time. So we've got on one hand the specialization, what we've briefly discussed, and what follows that is actually the complexity of the instruments. We are getting more and more super complex instruments that really require bespoke solutions. And this is one of the elements that we will have to sort of get used to, that we will no longer have, one or two cycle profiles and everything just goes through them, that we will have dedicated programs for different types of surgical instruments. So you will have different programs for robotics, different for ophthalmics, for neurosurgical, for orthopedics, because this is where you can actually capture the efficiency. You can then optimize cycle parameters to the level that it is not possible currently when you are just trying to put any type of instrument through the washer. So this is, I would say, the first element. Second element is the antibiotic resistance, which is a problem that goes way beyond decontamination, but the decontamination sciences are sort of on the receiving end of the problem, because what we had so far was the luxury that should there be an infection after the surgery, we always had that last resort. We could put antibiotics, we could put a patient on a higher dose of those drugs and eventually resolve the problem. So now imagine, as we are having more and more antibiotic-resistant microorganisms, what actually happens if we don't have that last resort. Those patients who are for some reason weakened, who are immunocompromised, will have a tremendous problem, because we were not really capturing that, even statistically, how many particular infections were actually coming from surgical instruments, because yet again, you knew that there was a fairly simple solution in case of antibiotics. But if that is no longer going to be a viable solution, then we will be scrutinized much, much further in terms of the quality of reprocessing and the quality of the output that we produce.
Yeah, it's no surprise how reimbursement has changed in the United States for that reason specifically. And Pawel, you really, I think, outlined a lot of the issues at hand. I also am really interested in how your technology combines so many different methods into one machine, and we may have to table that for a future show, because I know Hank and the team are really getting excited to talk to you also about virtual reality, and we're going to come back in just 1 minute to talk about that. Everybody stay tuned. We'll be right back. We're back with Pawel de Sternberg Stojalowski, Managing Director, R&D Engineer, and Consultant for Decontamination of Medical Devices at Aseptium. And before we dive into the virtual reality applications, obviously Aseptium is doing some real cutting-edge work, Pawel. I wanted to maybe give you a moment to give us a little bit more of a background to Aseptium and what you're doing there, and then we can dive into the conversation around how virtual reality can be such a help in the administration or delivery of this technology.
Basically, at Aseptium, we specialize in high-end technologies for decontamination of complex instruments. So we develop and manufacture cleaning and disinfecting equipment, but we go forward with the approach of developing the technologies, because at the end of the day, if you develop cleaning or disinfecting equipment, it will be also nice to find out how well it performs. And for that reason, we've also created our own process challenge devices, and that was predominantly to find out how well our washers are performing, how effective the cleaning is. And another element in that conundrum that we are trying to address at the moment is referring to the changes in the types and the complexities of surgical instruments that are being developed at the moment. We are also looking at bespoke solutions dedicated to particular groups of instruments and decontamination challenges. So that really nicely wraps up the group of things that we are doing. And one element that I wanted to stress out is that from the very beginning, we had this idea of putting a certain philosophy into developing new technologies. And first of all, it was the use of the scientific method approach, testing whatever we do and making sure that we are as confident as we can be on how effective particular solutions are. The second element that is very close to also my background is full automation of processes. We believe that the automation of processes is the real answer to the quality, to the final output, to being able to fully validate every single element of your decontamination process. The last element here that is also super important is the fact that we are looking at knowledge sharing and international outreach. And I think that this particular podcast is a fantastic example of trying to reach out across borders and trying to find out what we can learn from each other across borders, what different regulations in different countries bring to our greater understanding of decontamination processes. And I'm delighted that in the USA, we already work with people from QPRG, Dr. Jonathan Wilder, who is an expert in the field of decontamination, and he's been in the field for a very long time, and also Brian Fortier, who's got a tremendous experience with implementation of complex instrument washers and looking at improvement in processes. For us, it was fundamental that we actually link up with people who are experts in their respective fields, and we grow not only the business side of Aseptium, but also the pool of knowledge that becomes available for everyone to use.
That's a great point, Paul. The vision, I guess the perspective that I like to throw out there is these challenges that we're discussing, they really are global challenges. And so the solutions that we should be talking about should be global in scope as well. The fact that we're operating in our own silos, sometimes without the terrific work and support that other very bright and very passionate folks are working on across the oceans, that's important to connect. So it's a pleasure to be able to do that on the show for sure today. And I want to get at this technical conversation regarding virtual reality and augmented reality. And I think for a lot of us, and I'm including myself, there's a little confusion between what those really are and how they're different. As we start this segment here, can you maybe start us with a definition of those two technologies and then begin that conversation of how they can be applied in a decontamination context?
Virtual reality and augmented reality are new technologies that help us to visualize different things. And let's start from virtual reality. The concept beyond that is that everything that we see is virtual. So we end up being almost like inside of a computer game. We put glasses or goggles, VR goggles on, and we are being immediately transported into a completely different virtual world. So what we see is all generated by the computer. The augmented reality, the difference is that augmented reality is the real world, everything that we can see around us in a real world. And then when we put augmented reality glasses, what we get is elements of the virtual world being imposed on the reality that we see around. So you can see around, like I'm sitting at the moment in a conference room and I see walls, I see table, I see my computer. But with augmented reality glasses, I can add elements to what I see that are virtual. So I hope that this sort of wraps up and is clear in how those two different technologies work and how they differ.
So what is your vision then for applying virtual reality in particular to the science and technology that your company is focusing on?
So the virtual reality, and this is when we create completely immersive experiences, is a fantastic tool where you have the ability to visualize very complex problems, situations, and case studies in a way that is not really possible in the real world. Imagine putting the VR goggles on and being transported into the world of molecules where you can actually see chemical reactions happening just around you. You will then understand exactly how different chemical elements bind together. This is something that you wouldn't be able to experience even using microscopy, because this is how we can then break down very complex problems, transport you to completely different worlds, and create situations that you wouldn't be able to visualize with any other means. So education and training, when we come back to the decontamination realm, there is a tremendous amount of complexity when we come to the junction where chemistry, physical processes of protein removal, protein detection, as well as contamination character, when all of those sciences come together, it creates a lot of confusion. So yet again here, the virtual reality will be able to allow us to create simulations, show you videos and animations of how particular processes work. And this is absolutely fundamental for us to understand how certain types of contamination are removed. What are the differences between, for example, the spray removal of contamination and flushing? Ultrasonics is another subject that is at the moment treated as one big black box where nobody really understands precisely how it happens that contamination is being removed, what conditions and what properties of ultrasonics are important from the instrument cleaning from protein, not only protein, but contamination removal. So education and training over here are the predominant trends that are going to drive VR applications in decontamination. Second thing that is also very interesting is process visualization. So yet again, we have the situation that at the moment we sort of have to imagine how instruments jump from one process to another, whether we can actually streamline it somehow. With virtual reality, yet again, having additional visual aids will be able to make it much quicker, much more easy to understand. The critical element of virtual reality is that we can also create worlds that are very familiar to us. So imagine that you can actually create a virtual decontamination unit where you can see every single machine, you can see how they behave, you can see how they interact with each other. And this is a fantastic educational tool, especially for new people in your department, where they can, in a very safe environment, immerse themselves in the working life of your department without breaking anything. And this is the important element here. Think about, at the moment, applications of augmented reality. This is a slightly different technology, and where we see the biggest advantage of using augmented reality is in the assistance, guidance, product support area, because this is when we can add more information to the real world for the user. This is when, for example, looking at a particular machine, you can see all the technical documentation. So from the perspective of a maintenance or service engineer, you approach a piece of equipment without a necessity or without the fear of the fact that you might have forgotten about a particular element of how it works. Everything is going to be given to you at the time when you are at the machine. Moreover, augmented reality also allows you to create a telepresence link where you can link up directly with the service center and talk to the most experienced engineers that will see exactly the same thing that you see at the same time. So they will be able to guide you and point you into the particular elements that you have to inspect, observe, and this way solve problems in a much quicker manner. So imagine that with the pair of, for example, augmented reality glasses, even in the hands of a hospital technician, you will be able to identify and diagnose problems. So when the service engineer comes to the field, they already know what they are dealing with. So the repair of this particular service part is much quicker and much more streamlined. So it takes less time, and at the end of the day, everyone gets the right value out of it.
And I think that's probably one of the most interesting applications of the AR is its application to specifically frontline technicians, especially in decontamination, but throughout the whole process. Could you talk just a little bit about what that would mean to raising the abilities of the individual technicians who are actually the ones who are responsible for cleaning those instruments?
So the classic example is actually when you have a very busy department with hundreds of different types of surgical instruments, and sometimes they come with specific instructions for reprocessing. It would then require a technician or a member of staff to either memorize all of those or have some sort of repository where the person would go to find out how to reprocess this particular thing. With augmented reality, they get the information instantly, because not only the software can recognize instruments, or you can program it to recognize instruments, it will give you all the required information. So yet again, you are cutting off all that idle time, all the inefficiencies that are not really linked to surgical instruments. It's just the nature of us human being forgetful and not being able to remember very complex things for a very long time. So augmented reality in this particular case is going to streamline all your processes, because all the information you require is really at hand. You've got it available, and all you need to do is ask for it. It's just as simple as that.
Paul, how much background work needs to happen on the development side of this technology to make that information profitable and applicable for those frontline technicians, because we're not just talking, and this is one of the existing challenges, I guess, on the part of CSSD professionals, is even when there are instructions for use that are made available. I opened up one this week, 242 pages, 7 different languages, and I had to use the search and rescue shortcut to find the particular paragraph that I was looking for. That's still not beneficial, even if it's on a Google Glass. There has to be some kind of connection there that specifies and outlines exactly what you need when you need it. Are we talking about, 5-10 years down the road until we finally got that level of connectivity, or are we closer than that?
I would definitely say that we are much closer than that. But as you have rightly pointed out, one of the biggest barriers for implementation of those technologies is actually creation of that content, is for someone to actually link up the instruction for use into your particular interface and being able to display them for you. So this is really that background knowledge that needs to be provided in collaboration between manufacturers and perhaps sterile services to find out what's the best way to display the information, how to recognize what is actually important in those particular cases. Because at the end of the day, virtual reality and augmented reality, it's a tool. It's a novelty at the moment that has got a great potential, but at the same time, it actually requires a tremendous amount of knowledge and support to actually create those virtual worlds and augmented reality features that will actually allow you to effectively use those technologies. So I'm thinking that it's definitely something that is coming up very quickly, but there is a tremendous amount of work in front of us to actually create the content that is both engaging and interactive through augmented reality.
Yeah, and just the ability to collect that information and parse it out, to your point, structuring the information is a big part of it. Kind of hoping, and we've had some dialogue about this on the show before, but maybe UDI law can help that information be updated and accurate on a regular basis and then integrated with augmented reality like you're talking about. But you're right. A lot of infrastructure needs to be put into place, Paul.
No, absolutely. And one element that I would also like to add over here is that I think that all technologies are advancing. So virtual reality and augmented reality are going to help out. But for example, in terms of the instructions for reprocessing of particular types of instruments, I would hope that in the timescale that we've mentioned, the 5 to 10 years, we'll fully automate the processes in a way that will require less and less of human intervention in those, and we won't need that level of augmented reality intervention because the processes will be actually fully automated. So what we have to find out at the moment is how, having the knowledge of what technologies are being developed and how we can use them, how do we actually shape the future sterile services department to answer and to make the best benefit of the new technologies that are coming?
Well, listen, this is an excellent interview, Paul, and I appreciate you coming on, as we said at the beginning, definitely at a completely different time there on the other side of the world, so to speak, at least across the pond. And I think there's a lot of interesting dialogue here that maybe we will have you come back again for a future episode and we can dive into some of those topics and maybe how we set up the infrastructure and all the steps that are going to have to be in place. But I wanted to thank you again. You've been an excellent guest this week.
Thank you very much for having me, and I'll be delighted to talk to you again. At the end of the day, I'm learning at the same time as everyone else, so it's a benefit for everyone. Thank you very much once again, guys.
That was Pawel de Sternberg Stojalowski, Managing Director at Aseptium. And Hank and Mike, this is really interesting, the combination of all these different technologies. I think cross-contamination during decontamination was a major takeaway for me, especially, I know we didn't dive too deep into it, but when we talk about antibiotics and multi-resistant bacteria, all of those topics are things that could probably have been shows in their own right.
Yeah, absolutely. And for me, the big takeaway is sort of where we're going in the future with the augmented reality. I know Hank has written multiple times about how ridiculous IFU following can be, especially when you've got, thousands of instruments out there. I think about the ability to communicate to my decontamination technicians in real time what each individual instrument's IFU is. That gets me excited right there.
The thing that stuck out on this interview was the opportunity through virtual reality to see what's going on inside in the workflow of the department. I think the opportunities there are endless when it comes to educating, not just educating, but engaging at the emotion level of, man, there are some powerful forces at work that it's not as simple as skipping a step or trying to do things quicker maybe than the manufacturer's IFUs recommend, because you can see the impact of that in a virtual setting if you're looking at your sink or at the ultrasonic machine. Great show, great guests. Can't wait to get this out to the audience.
All right, that's going to do it for this week's show. As a reminder, you can support Beyond Clean by subscribing to the show on iTunes and Stitcher. We'd appreciate a rating and a review as well. Your feedback is important to the show, especially if you have any topics that you'd like us to cover on a future episode, or if you'd like to share any pictures anonymously on our Instagram page. Just send us an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.